This is an ellipse. It's an oval-like shape where the sum of L1 and L2 always stays constant. Now, let's look at the points. These are all vertices. The blue ones represent the major vertices and the yellow ones represent the minor vertices. Looking at the dotted lines, the blue one represents the major axis, whereas the yellow one represents the minor axis. And of course, let's not forget about the center, which in this case is at 0, 0 and is represented by the black dot. Going to look at the ellipse equation, we see that it is x minus h squared over a squared plus y minus k squared over b squared equals 1. We know that h of k is the center, and now we will find what a, b, and c are. A on this graph is represented by a red line. This is the distance from the center to one of the major vertices. B is represented by the yellow line, which is the center to one of the minor vertices. Finally, C represents the center to one of the foci. For finding B, we could plug in b squared equals a squared minus c squared, since a is larger. To graph an ellipse, the first thing we want to do is find the center. Once we have that, we will plot it on. Let's take an example question. From this problem, we can see that the center is -2, 1. Let's plot it on with the black point. Right off the bat, we already have our answers. Since we know A is 5 and B is 3, we can just plot that as the distance from the center, that is the black dot we already have. This graph now shows all 4 vertices that are plotted on the graph. Let's connect them with a simple ellipse-like shape. As you can see, we have a very good idea of what the ellipse looks like. Now, you might be required to find the focus, but we'll talk about that in the next section. Part 3. Problem-solving strategies. When using ellipse, you will encounter different types of problems. For example, let's take our last equation and try and find both the foci. Now that we have graphed the center, let's go on to find what C is equal to. Using our previous equation, we can swap around some variables and get what we need. Plugging into our bottom equation, we get that c squared is equal to 25 minus 9 or 16, giving us c is equal to 4. Plugging that into our graph as 4 is the distance from the center, we can find our foci. If you encounter a problem that asks you to create an equation from a set of points, all you have to do is the vice versa of how to graph it. Find A and B from the points you have, and also find the center. Then, you should be able to construct your new equation. The ellipse you will usually encounter is called a horizontal major axis ellipse. This is where the sides are longer, but if you find one that's more vertical and the top is longer, that is called a vertical major axis ellipse. Be careful, because that means that the focus is on the y-axis instead of the x-axis. An equation that codes that types of ellipse might look something like this. The calculated crook has recently stolen hundreds of pieces of priceless work. In order to find the items, the FBI has placed 2 trackers at points -4, 0 and 4, 0. Surprisingly, the distance from any object to one tracker plus the distance from the same item to another tracker was always equal to 10 miles or units on our graph. Jumping to our Desmos graph, we immediately plot the 2 points we know, which are the focuses. There are 2 easy ways to find it. First, since we know the sum of the distances is 10, we get 2a is equal to 10 or a is equal to 5. If you don't know that, an easy way to find that is since 5, 0 works, because the distance is 9 plus 1, which equals 10. Using Pythagorean theorem in the 3, 4, 5 triangle, we find that the minor vertices are 0, -3 and 0, 3. From that, since we have A and B, we get the final equation as this. In this video, you learned all about ellipses, how to graph them, how to solve problems on them, and so much more.